Hello Team IBM. Our project is Smart Waste Management System for Metropolitan Cities using IoT, and I used the real-time hardware, and also I made a project with simulator also. So first I will explain about my real-time project using hardware devices. Here I am use Raspberry Pi as per constraint you given, Raspberry Pi 0W, an ultrasonic sensor, GPS Neo 6 and load cell. Okay, now explain the configuration. Here our Raspberry Pi 0W microcontroller used as a middleware to transfer data to Firebase and IBM Watson Cloud. So the data are fetched by load cell and ultrasonic sensor, and then obviously GPS live location. This data to Raspberry Pi, and they reach to my IBM Watson and Firebase. I connect my Firebase with web portal like user interface that show the real-time values from the ultrasonic sensor and load cell. This data push happening 10 seconds once, but in real time I transfer data 6 times per day due to the power consumption. And then from IBM we fetch data to Node-RED and show the output in UI of Node-RED. Then the data from Firebase forward towards Applux and web portal. Applux is a APK to monitor the garbage. Here I use Node-RED, so we have optionally choose the device Node-RED to indicate with light blinking, so they recognize the dustbin get filled, so they clean that dustbin. Just a further input than IBM constraint. These are my overview of my smart waste management system using IoT, and here I will show the real-time working principle of my device. Okay, now I taken the ultrasonic sensor for calculating distance of the trash. This is a web portal. Here I have the live map and percentage and load and distance of my garbage. Once the distance is calculated, the page automatically refresh and show the value. So here you can see risk warning is producing. So this alert message pushed towards the truck drivers and web portal also. If there is, we have added three constraint like three notifications. One is a risk date, and another one is dumpster is above 60%, and another one is dumpster is above 50%, and at last and no need to collect garbage. Notification pushed over the truck drivers and authorized person we fixed in our condition statement. This is our load cell. Once the pressure happens, it will show the values in web portal. That's it. For IBM Watson portal, here the data are pushing from Raspberry Pi to IBM Watson cloud that are shown here. This data are sent in the format of JSON and string also, as the raw metadata, as well as we can see that how many data is pushed, how the data is pushing, what are the data is pushing, what the token status, what the data format, string, JSON or any other extra format. We can monitor everything in IBM Watson. It's very useful for us. Here I fixed all my hardwares in my dustbin. Just imagine this dustbin as real-time metro cities garbage. So I just deploy and show how it's working in real-time environment. Here you can see the live data are pushing from the dustbin to my terminal. So this data are pushing towards the web portal also, and we have named the device as dumpster. Once we click, it moves towards our GitHub page. And this is our dustbin. Here we fix the ultrasonic sensor. This ultrasonic sensor have the condition statement, and this is our hardware. Here we have used a Raspberry Pi and GPS module inside this. This is a power supplied with my lap. On the bottom of the dustbin we have kept the load cell. Here you can see the load cell. This is our hardware device, that is Node MCU. This connected with my Firebase. Once the rest state attend, this start blink in green color. This is the total overview of my real-time project with the Raspberry Pi and other stuffs included with IBM constraint. So, and I can also show the simulator using Python. Here also I used Python as a main language for Raspberry Pi, and I used to run the code with shell. And this data are pushing to the Firebase as a cloud and IBM as a cloud. And for the web portal I used HTML, CSS and JavaScript to show off my data there. Hello IBM team, this is our final simulator project. Here we code with Python and this Python script generate the random values for distance and load, and we constantly fixed the latitude and longitude value here with our location. This print in my IBM cloud and as well as this terminal. Okay, it's based on Metro City, right? So we created the 4 bins and 4 random values these bins generate. This how we just installed our bridge ID. This will redirect to our IBM Watson cloud, and we kept the condition statement here. This shows the alert message in terminal. I just run this module and show the output. Okay, here you can see our location and alert message, and the data is successfully pushed over my IBM cloud. And I run my 3 bins here. Okay, and these 4 bins are connected to my IBM cloud. Here you can see that the values are pushing over here, right? Okay, this data is successfully pushing in my IBM cloud. So I just push this data in JSON format in my Node-RED. Here you can see I just ping the IBM IoT to transfer the data to this gauge. Here I made a function just to measure payload that distance is passing to this gauge. This just building blocks I fixed here. This is our dashboard. Here we can see the real data from the Python script. The first spin value is 23, the trash is in 23 and kg is 11, as well as second is 12 and 11. Third spin is 30 and 8. Fourth spin value is 11 kg and 50 centimeters. Yeah, these values are randomly shifting from my data where I pushed. Here you can see the last value is 15 and 8, and 15 and 8 is my first bin value. So this is a simulator, and I also done with real time. I explained that before this simulator. So thanks for this wonderful opportunity, IBM. This is very useful to learn the advanced technology like Node-RED, and we learn more about IoT as well as how to connect with IBM Cloud. This is very useful for us. Very thankful for you and explore more people's. Yeah, thanks. All done.